So this is again the orientation to the various aneurysms. So now we'll get into the steps. So first is the make an incision over the dura over the anterior clinoid process. So this is the anterior clinoid process. So here this is the anterior clinoid process, and here is the optic nerve entering the optic canal along with the ophthalmic artery. So now make an incision over the dura over the anterior clinoid process. So you make it in a way that the flaps are reflected so that the optic nerve is protected with these dural flaps. And then unroof the optic canal. Okay, unroof the optic canal and cavitate the anterior clinoid process. So once this is done, the anterior clinoid process can be removed away or it can be completely drilled out. So once the anterior clinoid process is removed, then what needs to be done is open the optic sheath. So you need to open the optic sheath. So once the optic sheath is open, then incise the distal dural ring. So incise the distal dural ring. So once the distal dural ring is opened superiorly, then incise the distal dural ring medially. So you open it superiorly and then you open the distal dural ring medially. So now the ICA can be clearly skeletonized. So once it is done, then incise the distal dural ring laterally and inferiorly. So once the distal dural ring is completely incised all around the ICA, now the ICA can be easily skeletonized and the aneurysm can be visualized. The origin of the ophthalmic artery here is clearly seen, and now the aneurysm can be easily clipped. So this is the simple clipping, the tandem clipping, and the right angle to fenestrated clipping, which is usually used for superior hypophyseal artery aneurysms. So with this, we'll conclude the today's session with orientation to the DSA. So whatever we have discussed now. So just a summary we will see in this picture. So which one of the following is most likely based on this AP view of right ICA projection? Yes. So any guesses? So what are we seeing here? So this is the aneurysm. This is the AP projection of the cerebral angiogram. This is the ICA, which is bifurcating into lateral M1 MCA and the medial A1 ACA. You can clearly see the medial A1 ACA, yes. 4. No, this is what we have. This is a kind of paraclinoid aneurysm, and the only answer here in the paraclinoid aneurysm is superior hypophyseal arteries. Okay. So what you can see here is a superior hypophyseal artery aneurysm. Okay, so how to identify this is, so this is an AP projection. See, the aneurysm is projecting medially. Okay, this is the medial A1 ACA. The aneurysm is projecting medially. Okay, so this is a superior hypophyseal artery aneurysms. Okay. So the superior hypophyseal artery aneurysms, they arise just distal to the origin of the superior hypophyseal artery from the medial or posterior wall of the ICA, where the curvature of ICA is convex medially. In this location, they lie lateral to the pituitary stalk and point medially under the optic asp. The medial expansion of the aneurysm may compromise the perforating arteries to the floor of the third ventricle, the optic nerves, the chiasm, the pituitary stalk, and the hypophyseal vascular supply.